So first of all, thank you for having me online. I'm sorry for not being there with you on site, but still glad that I can present our groundworks this way. My name is Elena Sliptsova. I'm from Intellias company. We are a global software service company with more than 10 years experience in location-based services. And 2 years ago, we joined NDS community with the goal of staying at the forefront of the industry standards and contribute with our experience to the standard development. Today, we would like to share our experience with NDS.Live application services. Why this topic? We had 3 goals in mind. First one was educational. 2 years ago, Intellias launched Intellias.Lab. This is the joint laboratory with the Lviv National University of Ukraine, where we invite young talents to gain some hands-on experience with location-based services and the modern technologies, and NDS is a great suit for this purpose. The second goal is NDS community contribution. Application services is something new for NDS. It was introduced with NDS.Live generation of the standard. And to be honest, we haven't seen much discussions going around in the working groups regarding the application services. So we were curious to try and to provide our feedback to NDS, maybe to raise some interest to this topic among the other members. And of course, business goals, because we can reuse then our experience, our groundworks to boost our solutions for our clients. This is a high-level overview what was the scope of this educational activity, but we will focus today on the search and routing service, as Smart and Registry is some base that is actually developed by every company using NDS.Live. And the list of technologies and tools that we were using, all of them are open source and very wide used in the industry. Let's start with the routing service. NDS.Live specification defines actually 2 routing services. So first one is more classic one that returns the route from A point to point B and C and D. And the second one is the range projection service that returns the reachable area having some time budget or cost budget. This one is more interesting for the fleet management or last mile delivery use case, but it is here marked with a gray box as it was out of scope for our implementation, but just to remind that this service also exists and is defined. There are 2 communication protocols defined, the publish-subscribe topic as an interface between NDS and non-NDS systems, and the standard request response for the route calculation. And for route types, fastest, shortest, eco and green. So eco to define the route with the best fuel consumption, and green with the best with the lowest overall pollution. So we skipped eco and green. It required a lot of data from vehicle details. So we focused on the fastest and shortest ones. When it comes to the routing implementation, the main challenge usually is a graph calculation, because this is a very resource-consuming task. And with NDS.Live architecture, there might be 2 ways to calculate the routing graph. So first one is static, when you calculate the routing graph for all the map during the service initialization phase, and then you just use it. And the dynamic one, when you calculate it each and every time the user makes a request to the service. There are advantages and disadvantages for every of them highlighted on this slide. So for the static one, you always get a fast route computation for the end user. But with the dynamic one, you always get the latest and freshest map data. The static one is greatly scalable to support a large number of concurrent users, but the dynamic can also be optimized. So for example, it can be optimized to pre-calculate some common traffic patterns. For example, if in the morning everyone is driving from suburbs to the city center, we can already pre-calculate these routes. How did we fetch the tiles? Because also NDS.Live architecture requires you to come up with some mode of fetching the tiles from the smart service. So for the static approach, it's obvious. You just take the full map and you convert it into the routing graph. With the dynamic one, we started with the most obvious one to fetch the tiles along the route. But it gave us a lot of edge cases because 2 tiles is usually, sometimes it's not enough to perform the necessary driving maneuver. Then we tried the Manhattan distance, so taking the diagonal from the origin to the destination and fetching the square around this diagonal, also with some buffer tiles in the beginning and in the end to perform the necessary detour if it's needed. And this one worked pretty well. This is a high-level routing service architecture. We have on the left the theoretical navigational system. We do not have a real one, unfortunately, or the routing inspection tool. I will highlight here that currently the tools provided by NDS organization, they do not support some visualization for application services. So here we had to develop our own tooling. We came up with some web-based tool, and we needed to convert zero data structures to make it more native for the web tooling. Then we have route calculation engine that using the vehicle details, route calculation preferences, and dynamic cost function calculates the optimized route based on the routing graph that is calculated in the route graph engine. And on the right, we have our NDS.Live map ecosystem with the traffic events and the smart service. This is a short demonstration of the service work and our web tool that allows to visualize and to test routing service. So let's imagine we arrived to the Tokyo airport, as a lot of you did yesterday, and you want to drive to the Zenrin office. We are selecting the shortest route, and service return the route that is visualized on the map. Now let's imagine we still have some free time and we want to visit a Skytree before going to the office. We are setting a point, interim point, and the route is pre-calculated via this point. The service allows to set some avoidance options, and let's imagine we want to avoid motorways and the tunnels. We have a tunnel underwater here, and it should guide us through other route. And here we have a change. This is a not strict restriction to avoid tunnels, so we just add some weight to the graph edges, but if it is possible to avoid, the service will do it. Now going to some other district to demonstrate the alternative routes calculation, setting origin and destination point and calculating 3 different routes to select one of them. And here we have 3 routes calculated. Fabian mentioned in his presentation that NDS released Open Drive Converter for the NDS.Live data, and we thought that this is a good idea to have something similar for the services as well. So we tried to prototype converter from routing service or routing structures to the open scenario that is used to simulate the driving maneuvers, and a short presentation of this functionality. So we can select the route on the tool, we have the guidance instructions, and using the ES Mini simulator, the route is converted to the open scenario standard, and the driving through the route is visualized in the simulator tool. So it is driving on the left lane of air. And we are getting to the destination point. What we learned from the routing service implementation? So we really enjoyed the comprehensive set of routing types and parameters and the customization of routing modes. The route segments classification and the guidance instructions that you have everything in one piece, and it's quite convenient. And NDS.Live standard and architecture by itself guarantees the map data freshness. What was challenging? Of course, lack of visualization and evaluation tools. The real-time data feeds integration. So currently, standard doesn't provide the possibility to update the route during driving using traffic. So if you have some faster route, you cannot update the driver with this information. And in production, there might be challenging to have the horizontal scaling of the service. And some ideas, what can be introduced to the standard. So first of all, the routing graph data structure. So to have the dedicated data structure to store the routing graph. The destination point adjustments, for example, it can be some enum that allows you to set if you want to be guided to the nearest point of the destination, or for example, you want to find the nearest parking or the nearest spot outside of the low emission zone to have the more destination points adjustments. Of course, there is always room to improve the personalized routing by some driver preferences and extend the EV support by adding the automatic stopovers for charging based on battery anxiety, or for example, adding the battery, the charging type, and other parameters specific to a car. As I already mentioned, route update functionality to be able to update the route if the traffic situation has changed. Extend some avoidance preferences to set, for example, to be able to set some area that you want to avoid while driving. So currently there is no such possibility. And to the route types, there might be also the cheapest route added to avoid tolls, for example, or calculated based on the fuel consumption. And of course, it would be nice to have the combination of different route types. For example, I want to have the shortest green or the shortest eco route. And the last one, best time slot calculation for a given route. That is all for the routing service. Now a quick overview of the search service. NDS.Live specification defines two services here as well. One is the search and another one is the geocoding. These are two separate services. Search features is quite a comprehensive list of the features that covers all the needs for the modern search systems. So you see the strike-through items. These are the ones that we did not implement during our prototyping. And there are 4 search server configurations, so address, POI, next valid character, and suggestions for auto-completion. The high-level service architecture for search, it is quite similar to routing one. Here it is worth highlighting that we are calling the routing service from the search to calculate the distance to the selected POI, for example. And talking about what is inside, so we are using the Elastic database for this. So first of all, NDS.Live data is converted to the JSON-like structures. It is then indexed and stored into Elastic database, and then from this Elasticsearch, we already perform search. And for semantic search, we are using LLM to improve the accuracy of the results. Here we also had to develop the simple web tool to be able to test and demonstrate search service work. Let's take a look. So we will start searching for the Zenrin office location, and it suggests some other POIs with the similar addresses and can visualize that on the map. Now we select the POI that we really need, and we see it on the map. Next type of search is a search around, when we can set the origin point, draw some circle to select some area. So we are selecting the big area and searching for the airport. Service helps us with next valid chapter suggestion, and it finds the airport with the distance calculated. So this is the routing distance, not the direct distance. And we see the airport here. Now I will demonstrate the semantic search in geo area. We select some polygon around the conference location, and let's say we want a place to eat ramen. And service returns us 10 different options showing results on the map. So you can use it if you are hungry. Okay, and geocoding service. So here we can select some location on the map. This is some supermarket nearby, and check the address. It returns the address string with the full administrative hierarchy for this address. And the geocoding service, by entering the address of the office center, it returns the latitude and longitude, the coordinates of the point. Quite simple. What we learned from search services implementation. So we enjoyed the comprehensive set of search types, options, and the geocoding is a separate service, was quite convenient for the implementation. The request response settings are very flexible, and the architecture allows to perform server-side filtering, and this improves highly the performance of the service. And search enhancement based on some user preferences. What was challenging? NDS documentation navigation sometime for the services, because you need to search like for different data structure on some different pages, the lack of visualization and evaluation tools, and we found some inconsistencies in specification that I raised in the poll that was sent by NDS a few weeks ago. And some suggestions how to improve and widen the standard. So there might be search for areas with multiple entrances, like some big national parks or some big venues, so that you can find different entrance points. The result sorting by ranking, so there is an attribute star rating, but it is not used somehow by the service, so it can be used to rank the results for the users. And would be nice to introduce the administrative hierarchy layer, because currently we need to duplicate administrative hierarchy information for every item. To summarize the key takeaways of this activity, so we see strong advantages of using the NDS.Live application services. First one is, of course, moving of computational efforts to the cloud. Native for NDS data structures, registry service as entry point to the NDS ecosystem. So you have one entry point to the whole ecosystem of map and services. And it allows the bidirectional vehicle data exchange. Challenges that we see currently is, of course, the SDK update. It is always very costly for automakers to make SDK updates, and if you switch to some other services, you need to do this. Internet connection dependence, it is harder for application services to make some workaround like for the map. So for the map, you can cache some tiles around the locations, but for the application services, you never know what user is going to search or what point he wants to set as the destination point for his routing. So it's a bit harder to come up with some solution here. And currently lack of certification and tooling to work and test and evaluate the services. We are seeing some next steps here in this activity, so maybe with the next generation of students. So we have idea to integrate with parking info providers for some dynamic slots availability, integration with venue maps, integration with providers for safety-related traffic events. This is a crucial topic currently for all the industry, as this is becoming mandatory. Integrate descriptive information about POIs for LLM-powered search that will improve the usability of the semantic search. And for routing, it can be graph neural networks to improve the routing calculation. So we will be happy to discuss these groundworks with you. If anyone else is interested in the application services, would be nice to share feedback and share thoughts. Thank you very much, and I will be happy to answer any questions.
Yeah. So thanks, Lena. I'm not sure people were clapping here, so I'm not sure whether you could hear it. So the room is quite full. Unfortunately, you cannot really see it. Anyway, questions to Lena? None? Yeah. Cool. In the reach of the cable. Good.
Good. Hi, Elena. So nice to see you. And thank you so much for actually diving into application services. That's something that all of us have been thinking about, but not really gotten to yet. We are just in the data service realm. And this is a question which our internal teams often ask because companies like TomTom, we already have very mature application services out and running in the field. And there's almost this obvious question about, but why should we change the interface and have an NDS.Live based application service? So what, in your opinion, would be the top 2-3 advantages of actually trying to invest in an NDS.Live based application service?
As I already mentioned, this is the one ecosystem, right, for all the services. And from our point of view, so the maintenance of such services, which will be much cheaper, right, than the current one, because you will be working with all the native structures, so the development and the maintenance of it will be easier. And of course, as I already mentioned, so they're moving everything to the cloud, but of course, I assume your application services, they already all work in the cloud as well, right? As NDS.Live. So I guess, yes, the most crucial one is the maintenance of this and introducing some new features, updating the services when they are already in production.
Thank you.
Okay, more questions? Yeah, Otto is arriving.
Yeah, hello, Olena. It's a pity that you cannot make this trip to this conference, but yeah, thank you very much for your presentation. One idea is that have you ever thought about to offer it also as an evaluation service for the members and maybe for the evaluators?
Not yet, but we will discuss it. Good idea. We will discuss it internally.
Yeah,
Thank
you also
you.
mentioned that the tooling is not yet available. No certificates, no tooling from NDS side. So I'm assuming it will be also challenging for the NDS Association as well to host such a service. But now that we see it's live, it's working, probably it's worth to think about it further and yeah, maybe work jointly on that, how to make it samples evaluation service available for the members and evaluators.
Yeah, thank you, Otto. That is a good idea. So we will discuss it after the conference.